But, there are, hundreds of thousands of these things in the main belt. And over the last 25 years, we've been discovering a lot more in a different belt, which is out beyond Neptune. And there are many, many, many minor planets out there, millions and millions of them. Wow. And again, part of my research is I'm interested in those from the perspective of, well, we're seeing objects out there which are 50 or 100 kilometers across. Pretty big. We're not talking about little lumps of rock. We're talking about big. Really, we still call them minor planets, but actually they're comets. They're big lumps of ice with some rock mixed in essence. And I follow, I'm interested in their orbital evolution. So over timescales of millions to billions of years, like the age of the solar system, how often does one of those come too close, let's say, to Neptune and get flicked into an orbit which might divert it into the inner solar system? Because if that happened, we're in big trouble. A 100-kilometer object, you think about a 100-kilometer wide object, that can clearly be broken up into a million 1-kilometer objects. Then all of a sudden, you've got a real problem, because that's a lot more than all the Earth-crossing asteroids we see now. And events like that must have occurred during the history of the Earth. We know that there have been mass extinction events, which are linked in various ways to asteroid and comet impacts. We can't be sure which. I mean, people know about the dinosaur extinction 65 million years ago. They know about the fact that a crater has been, a very heavily eroded crater has been identified on the Yucatan Peninsula in Mexico. There's actually another 2 or 3 craters elsewhere which seem to be the same sort of age. So maybe it just wasn't a single impact. Maybe it was a big object which broke apart and some of the fragments hit the Earth. And all 3 or 4 of the craters which I've mentioned there are on land. Well, 70% of the Earth is covered with ocean. So maybe there's been impacts in the ocean, which of course we wouldn't see so easily the craters from.
Right.
So that's, that gives us pause, as it were. People say, well, 5 million years ago, but hey, take a look at a map of the US and take a look at Chesapeake Bay. That actually is an asteroid impact crater at Chesapeake Bay. That occurred around about, I forget exactly how long ago, 31 million years. Is that correct? I don't know. But that was an asteroid impact. In fact, there's a type of glass. It's natural glass. They're called tektites. They're little black lumps of glass. It's clearly melted rock, which is re-solidified when it's flying through the atmosphere because they have these ballistic shapes. And there's various what are called strewn fields of these around the world. There's a strewn field in Africa. There's one in Southeast Asia. But there's one in Eastern Europe. So lots of these things are found at a certain level in the strata, and so of the same age. So it seems like an asteroid has hit, gone kablam, excavated a big crater, melted lots of rock, and some of that has flown through the atmosphere as melted rock, and it's re-solidified as it flies as little glassy lumps, which can be up to the size of your fist, but mostly the size of your little fingernail. And some of those are teardrop shaped. Some of them are little dumbbells, but they're clearly, aerodynamic, as it were. Some are actually shaped more like buttons, which shows, they've been traveling real fast through the air as they've solidified. But again, there's a strewn field in the eastern US. And if you know where to look, you can find these things. And that's from that impact from Chesapeake Bay. Again, very few people living in Washington or studying at Annapolis, know this.
Yeah.
But guess what, guys? There was an asteroid impact there a long time ago, and that, in essence, is a large part of why Chesapeake Bay is there.
Man.
So worked in that kind of area for many years. I find it interesting. It's different people find different things interesting, and it's interesting stuff in that it's we want to know how life has evolved on the Earth, what the influences have been. We're going to understand what's going to happen in the future. We do need to understand the past.
For sure. So if if an asteroid or something was coming to hit us, and we were able to predict it and see it coming, I guess it would probably depend on what it is exactly and everything, but would there generally be something we could do, or is that how? No, can we not?
Well, obviously it all depends on how much warning you've got. The movies always have short-term warning, but the reality is no. You can expect hopefully, if we do the search programs properly, we can expect a lot of warning. I'll give you an example. There was an asteroid discovered in 1950, it happens, in a program which was sponsored by the National Geographic Society. It was discovered from Mount Palomar. And it's now called 1950 DA still. And the reason is that it's got a permanent number. So like 4713 Steel is my asteroid, if you like. I don't own it. Nobody owns the moon or the asteroids, but that's the one that's got my name. 4713 is this permanent number in a list. It starts with number 1 Ceres, CERES, which was discovered from Palermo in Sicily on the first day of the 19th century, January the 1st, 1801. And so we're up to over 100,000, and a lot more than 100,000. 1950 DA has got a permanent number, but it hasn't been given a name yet. And the reason is that people who discovered it in 1950 have long since gone, I'm afraid. And so there has to be a certain length of time, 10 years, I think, after numbering, in which it's kind of being held in abeyance, and sooner or later it will get a name. Maybe it has already, because I haven't checked in the last see whether it's got a name yet. But anyway, that object, 1950 DA is the way I remember it. That has a slim chance of hitting the Earth on a known date at a known time, but in the year 2800. It's nearly 8 centuries away. So do we worry about it? I don't think so. But we will be tracking it. The current estimation of the chance of it hitting the Earth, and it's quite a big asteroid, by the way, it's a few kilometers in size. Chance of it hitting currently is estimated to be about 1 in 300, according to our best knowledge. But our best knowledge is not limited by lack of definition of the present orbit, because we've been tracking it now for 69 years. We know its orbit pretty well. The real problem is this: we don't know enough about its surface properties. How does that affect it? Well, the problem is that asteroids are absorbing sunlight, and they get warm, and they re-radiate that energy as thermal infrared, we call it. It's a different wavelength, longer wavelength. But both the absorbing of the sunlight and then the re-emission actually cause a type of, if you like, jetting force upon it. It's due to the, if you like, the pressure of light. That leads to an uncertainty in exactly what the path taken by that asteroid will be over the next 8 centuries. And that may seem like bizarre. What on earth are you guys talking about? But I can assure you, there are people studying this thing. We've got radar returns from it and so on. We've got the orbit well determined. We cannot say for certain what will happen in 800 years' time. And lack of knowledge of its surface properties. Now, obviously, 800 years, we'll let future generations worry about that one. As I said earlier on, in fact, we are able to predict the paths of asteroids out to about a century into the future. And that's obviously the only period which is of real concern to us. We, our great-great-grandchildren, look out for themselves. But if we were to discover an object, let's say, I always use 23 years as an example. Let's say we were to discover an object which we think has got a real good chance of hitting the Earth in 23 years' time. There isn't one that we know of, but let's take that as being an example. That is the sort of warning which we can certainly generate. We have the technology, scientific understanding to do that. It's just a matter of doing it. And most research programs are running in the US, have been for a long time. My research program in Australia was closed down in 1996 by the Australian government. We thought it was all a lot of bunk. Okay, but the Southern Hemisphere is very poorly covered. We need more research in the Southern Hemisphere. We need more tracking in the Southern Hemisphere. But let's say we did find an object and we said, hey, look, this looks like it's got let's say a 50-50 chance of hitting in 23 years' time. What can we do? Well, the reason I use 23 years is this, that if we change its speed in any direction by 1 centimeter per second, it will miss the Earth. The reason for that is if I multiply the number of seconds in 23 years, which is a big number, by 1 centimeter per second, then I get a number of centimeters. I will be diverting it. And the answer comes out to be the radius of the Earth plus 400 kilometers. So therefore, we can get it to miss the Earth. Now, that's got a hand-waving argument, if you like. It's more detailed in technicalities and so on. And there are all sorts of other things we might do. But if we had 23 years warning, we only actually need to change its speed by, like I say, 1 centimeter per second. Remember that these things are flying through space at tens of kilometers per second. So it may not feel like it, but right now,